Hi friends, welcome to my channel. Welcome to day 14 of our daily code challenge. I'm happy to be here and I'm also happy to have you around. Thanks for thanks for coming. Okay, so today is day 14. I'm so excited. Really, I'm so excited because I never knew I could get to this point. When I started this, it was like, wow, this is gonna be a very long journey. But here we are, day 14 already. So let's head over to today's challenge. So I'll just close day 12 and day 13. All right, so let me review the challenge we have for day 14, which is today. All right, we have Fizz buzz, right? The instruction says define a function fizzbuzz with a parameter called max that takes a number and prints every number from 0 to max. The maximum number here is not inclusive. That is divisible by either 3 or 5, but not both. Wow, this looks like a very good one. I think we need to really put our heads together and work this out. Okay, so let me just zoom in a little. All right, what do we do? What is this saying? What is this challenge all about? Okay, just like the previous one we did, we need to iterate between two numbers. In our own case, we need to iterate from 0 to a number of our choice, which we call max. And we need to extract or filter out all numbers between 0 and this max number that is or that are divisible by either 3 or 5 but not both. So for instance now we have 15. We are not expected to have 15 in our iteration, right? In the values returned, right? Because 15 is divisible by either 3 or 5. But here we don't want a number that is divisible by both 3 3 or 5. So numbers like 15, 30, 45 should not be returned in our iteration. That means that what we actually need to do from the way I see it is we look for conditions whereby if a number is divisible by 3, let that number not be divisible by 5. Or if a number is divisible by 5, let that number not be divisible by 3. Let's see how we can implement that. I'm simply just going to begin with writing the function keyword. I say function. Then here we are asked to use fizzbuzz as the function name. Fizzbuzz with a parameter called max and a curly brace. Then what we need to do is to iterate between 0 and max. So we use our for loop. Like I normally do, I remove index and I only put I. Using index also works. It's just a name. It's just a variable name. So I remove this, and since we are not dealing with arrays as well, it will get to a point where we'll be dealing with arrays. When we get to that point, we'll be using stuff like this. But for now, we don't need this. So I simply remove this. You say let I equals 0 because our starting point is 0 according to the instruction here. It says from 0. So we start from 0 to max, not inclusive. So we say I less than max because we are not including max itself. If we were to include max, we are going to say I less than or equal to max. Okay, so we want to iterate through every number. So we go in a step of 1. So this is okay. Let's console what we have and see if we are on the right path. Let's log I, then let's call the function fizzbuzz on, let's call the maximum number 45. Let's save and let's run our code. Okay, it's taking some time. It's taking some time. All right, so it's up. Here we can see that we have iterated values from 0 down to 44 because the max, which is 45, is excluded according to what the instruction wants us to do. Max not inclusive. Like I said, if we want max to be included, we would have simply just put an equal to sign here, meaning max should be included. So we save. When I run this, we get up to 45, but that's not the case here. We don't want that. Now, how do we get numbers that are either divisible by 3 or 5? Let's first of all work with numbers that are divisible by 3. Let's comment this out. So we use the conditional statement. We can use the conditional statement. That works. Or we can as well choose to use other ways that are okay for us to use. So let's just use the conditional statement. Let's say if brackets curly brace. Here we say if I modulus 3 equals 0. Let's put this inside the if statement. Then we remove the comments. Let's save this. So this means that if an iterated value is divisible by 3 without any remainder, print that value out. So as much as the values that will be returned that go with this condition all get returned. Let's run this and see. Here we have 0, 3, 6, 9, 12, 15 down to 42. So this satisfies this condition. What about if it were 5? Let's see what 5 is going to give us. I save this and I run. Okay, we have 0, 5, 10, 15, 20 down to 40. All right, so this also satisfies this condition. Let's remove this 3, excuse me, and let's remove the 5 rather and put 3. All right, so we say I modulus 3 equals 0. Now, how do we solve this in a way that the number should be divisible by 3 without any remainder, but not divisible by 5 without any remainder? What we are going to do is simply we come here and use the logical AND operator. That's a double ampersand symbol. Here we say I modulus 5 not equal to 0. Let me save this. What this is saying is, or rather what I mean by this is, if we remove this not sign, it's simply going to mean that this number should be divisible by 5. Since we said the remainder should be equal to 0, that means there is no remainder. That means this number is divisible by 5. Whatever number I is divisible by 5. But in our own case, we don't want any number divisible by 5 to be returned because we only want all numbers divisible by 3 to be returned. This is just what we want. And we want no number divisible by 5 to be returned. Then we say I modulus 3 equals 0 and I modulus 5 not equals 0. So to separate our work properly, or we could just leave this like this. Let's leave this way. Let's save and run the code. All right, we have 3, 6, 9, 12, 18, 21, 24, 27, 33, 36, 39, 42. Here, there is something very, very key we need to understand here. When you look at this code, we realize that there's no number here that is divisible by both 3 and 5. Numbers that are divisible by both 3 and 5 are 15, 30, which we don't have here, right? So I believe this is the code implementation to this challenge. Since it runs fine, that's it. Or we could also add something else. What if the number is divisible by 5? Because if you look at this very well, we notice that we don't have 5 here. So this is just return values that are divisible by 3 only. We can't see 5. We are supposed to have values that are divisible by 3 or 5, but not both. So as we have 3 here, the next number should be 5, then 6, 9. We are supposed to also have 10 because 10 is divisible by 5, but not 10 here. How can we do this? What we what I think we can do is we just copy this, or we could just copy this, duplicate it, then replace. Okay, let's solve it together. Let me place this one in a bracket. All right. Then here we are going to repeat almost the same thing we have here, but with some slight changes. Here we simply just use a double pipe symbol, which means the logical or operator, and then we put the parentheses. Then we say I modulus 5 is equal to 0, and I modulus 3 is not equal to 0. Just like we did here, the same implementation we have here. But in this case, we want every number divisible by 5 to be returned. And if that happens, no number that is divisible by 3 should be returned. And we put a and in between. This simply means that we don't want a number that is divisible by both 3 and 5, because the question says either 3 or 5, but not both. All right, so let me save this. Let's run and see if our code works well. All right, I run this. And now we have a different series of values. We have 3, 5, 6, 9, 10, 12, no 15, because 15 is divisible by both 3 and 5. We have 20. 20 is divisible by 5, yes. 25, yes, but we don't have 15. All right, we don't have 15. We are not expected to also have 30. Let's see if we have 30. 24, 25, 27, not 30. It skips 30. We have 33, 35, 42. So we don't have 45. Not because we excluded max, but because 45 also is divisible by both 3 or 5. Okay, let's change 45 as our as the argument. Let's change it to 50 and see if 45 gets returned. We save this, then we run. So here it stops at 48, and we can't find 45 in this series. So this code implementation solves the challenge that we've been presented with. And I must say this is challenging, right? But I'm excited that we're able to solve this. I believe with constant practice, when I say we, myself inclusive, we get very much improved in how we tackle problem solving, especially when it concerns programming, right? All right, so on this note, I'll just say thank you for joining on this call. Thank you for joining today's challenge. I'm so happy you came around, and thanks for having me as well. Have a nice time. And also, don't forget to join us tomorrow. Tomorrow, we have another exciting challenge to solve. So, let's make it a day tomorrow. All right, so have a nice time. Bye, everyone.